Hello friends, I'm Vinod Prabhu and I thank you for visiting our channel 7 Sense Aptitude Prep. I hope you have found it useful. If this is your first visit, I hope you find it useful as well. Today we are going to look at the third video on time, speed and distance. Today's video would be on the pattern of late, early and on time. So what sort of questions would there be? You would have Ramesh and Suresh are brothers. They go from the home to the mall. Ramesh goes at 30 kilometers per hour and he's early by 5 minutes. Who's the other brother? The second brother who is going from home to the mall goes at 20 kilometers per hour and he's late by 15 minutes. What is the distance from the home to the mall? So you could have two of them being late, two of them being early, and one of them being early and late. We find the distance between the start point and the end point. We look at two methods to solve. One is known as the time chart method. The other is known as the usual shortcut or the formula method. Okay. So the time chart method, what does it say? If it says Ramesh and Suresh, right? Ramesh and Suresh. If they are going from the home to the mall, we'll take that as D. Let us say Ramesh's speed was 30 kilometers per hour and he was early by 6 minutes. Suresh's speed was 20 kilometers per hour and he was late by 5 minutes. So they ask you to find this distance. Now let us take the time taken by Ram as T Ram Ramesh. Okay, and the time taken by Suresh is T Suresh. We'll make an assumption. Let us say the correct time to arrive at the mall was 9 o'clock. Ramesh is 6 minutes early, so he is at 8:54. Suresh is 5 minutes late, so he is at 9:05. What is the difference here? This difference, or rather this time interval, is 11 minutes. Correct? So it's 11 minutes. Now, T of Suresh minus T of Ramesh. Okay, Suresh is taking more time than Ramesh. By how much time? 11 minutes. Now, distance we do not know. So T of Suresh is distance divided by speed of Suresh, which is 20. T of Ramesh is again D, which we do not know, by speed of Ramesh, which is 30. And this is 11 minutes. So do not keep it as 11, convert that into hours. Because if this is in kilometers per hour, this is in kilometers per hour, distance will be in kilometers. So time should be in hours. And then you solve, you get this as 60 is the LCM. 3 minus 2D is equal to 11 by 60. D is 11 kilometers. Okay, that is the time chart method. The thing to remember here is that when both of them are early or both of them are late, what is the approach to be taken? And if one of them is early and one of them is late, what is the approach to be taken? You have seen here that Ramesh was early and Suresh was late. Okay, so if one of the persons is early and the other person is late, you add the time, meaning you get it as 6 minutes plus 5 minutes, right? You add the time that one of them is early, you add the time where the other person is late, and that is the reason you counted that as 11. 6 plus 5. If both are early and early is subtraction, and late is subtraction. Okay, now we have seen this. Let us delete it and see what will happen if both of them are early and both of them are late. Let me just delete this. Okay, now We see, okay, so D is the distance, right? Now let us say this was the distance. The speed is still the same, but if it was 30 kilometers per hour, Ramesh would have been 10 minutes. Ramesh would have been 10 minutes late. Okay, it's the next question. But if it's 20 kilometers per hour, Suresh would have been 30 minutes late. So Ramesh is also late, Suresh is also late. Now, if you have to look at that distance like we calculated, D is equal to T of Suresh minus T of Ramesh. The time taken. What is the difference? Here we don't do 30 plus 10 because they are both late. Then we subtract. Why? This concept clarifies it. If the correct time to come was 9, Ramesh has come at 9:10. Correct? Suresh has come at 9:30. What is the difference in the time? Is only 20 minutes. See, this is 10 minutes late. So 9:10 to 9:30 is only 20. Please do not write that as 40. So the difference in time is only 20 minutes. So if both are early or both are late, you subtract. Here both are late. So you subtract 10 from 30 and write that as 20. So D of Suresh will be D distance by his speed, okay, minus D of Ramesh equal to 20 by 60. At 60, 3D minus 2D, at D as 20 kilometers. Okay, so this is how we approach. So this is known as the time chart method. Key things to remember is you assume a time, generally take it as 9 or 10 o'clock, and then see at what time the two people come in. If they are both early or both late, you subtract the time by which they are late. Here it is 10 minutes late and 30 minutes late. You do 30 minus 10, which is equal to 20 on the right. If one of them is early and the other one is late, you add that time. You specify the time they are going to come, specify the time the other person is going to come, and then find the difference between those two times. Remember, on the right hand side, the time that you take should be converted into the same units. Here we have kilometers per hour as the units for speed, so the time, the unit will be converted into hours. So you divide by 60, minutes converted into hours. There's another shortcut, the formula. The formula is also something that you will see, but you'll probably see that in the second question. Let's look at the first problem. A person reaches the stadium. Okay, so here it's the person's home. Here is the stadium. We don't know this distance. This distance is D. If he runs at 30 kilometers per hour, you could also take it as two people going, right? So if this person runs at 30 kilometers per hour, so 30 kilometers per hour, he is going to come in at 5 minutes early. So the correct time is 9. If he is running at 30 kilometers per hour, he is going to come in at 8:55. 8:55. If he runs at 24 kilometers per hour, he is going to come in at 9:05. So one is early, one is late. So what do we do when one is early, the other is late? We add. Okay. So this is by 5 minutes. This is by 5 minutes. 5 minutes early, 5 minutes late. So you add 5 plus 5. So time taken when he is running it at 24 minus time taken when he is running it at 30 is equal to the difference in the time. So when he's running at 24 kilometers per hour, he's going to need more time. Okay, because distance by 24. The denominator is a smaller number, so this value d by 24 will be bigger. So this is when he's running slow, this is when he's running fast. So what is that difference? Will be 5 plus 5, because one is early, the other is late, you get 10, but you do 10 by 60 because these are in kilometers per hour. Okay, if you take the LCM, you get 120, 5d minus 4d, 5d minus 4d is equal to 10 by 60. So d is equal to 10 by 60 into 120. D is equal to 20 kilometers. So if the person is running at 30 kilometers per hour, he would be 5 minutes early. If he runs at 24 kilometers, he's 5 minutes late. Stadium is 20 kilometers from the person's home. Let's look at the next question. We'll probably solve this using the formula approach. Or rather, the same question. Let's look at it, how we can solve it using the formula approach. Formula is this. The time taken d, the distance d, is equal to time taken, the difference delta t, into the two speeds s1, s2 by s1 difference s2. So what is delta t? We said if one is early, the other is late. It is, you add those times. If both are late or both are early, subtract the time. So here what is delta t? Delta t, one is early, one is late. So 5 minutes plus 5 minutes. So it is equal to 10 s1 into s2 into 30 into 24 by s1 minus s2. Formula d, the distance is equal to delta t into s1 s2 by s1 difference s2. Okay, so this will be 10 into 30 into 24 by 6. The 10 has to be converted into minutes. It is in minutes, it has to be converted into hours. So divide by 60. 31, 2 gives you 20 kilometers. Okay, the same problem we looked at in the time chart method and we looked at in the shortcut method as well. Let's solve the problems using the shortcut method. A person jogs at 10 kilometers per hour and reaches the ground 0.1 hours late. When he increases the speed by 2 kilometers, he reaches 6 minutes early. So this is, one is late, the other is early. So you have to add time. 0.1 hours late. How do you convert 0.1 hours? 0.1 hours doesn't mean 10 minutes. So 1 hour is 60 minutes. 0.1 hour is equal to 0.1 into 60. It is equal to 6 minutes. So he is late by 6 minutes and early by 6 minutes in the second case. Okay, so since one is early, the other is late, we add. So distance is equal to delta t becomes 12. What are the two speeds? This is 10 kilometers per hour. Increase the speed by 2 kilometers. In one of the videos we looked at, increases the speed. Let us say it was 10. As a recap, if the question is increases the speed by 20, okay, if the person increases the speed by 20, the new speed would be 10 plus 20, 30. If the question says increases the speed to 20, this new speed becomes 20. Okay, by would mean you add that to the original value. Increase the speed by 20, you add 20 plus 10 makes it 30. If it says increase the speed to, the new speed becomes that much. So d is equal to delta t into s1. S1 we know is 10. S2 is increases the speed by 2 kilometers, becomes 12. Okay, so this 12 minutes we write it as 12 by 60 into s1 difference is 2, right? 12 minus 10. Yeah. So we do 12 1, 12 5, 5 1, 5 2, 2 1. This is equal to 12 kilometers. So remember the delta t, which is in minutes, has to be converted into hours. So we divide by 60. Formula again, d is equal to delta t into s1 s2 by s1 minus s2. Because one is late, the other is early, we add those two times. We add 6 minutes late and 6 minutes early, it becomes 12. Okay, increases 2 or increases by is important. Delta T is now 12 in this question. A woman walking to a laughter club at a speed of 20 kilometers per hour reaches. So this woman goes at 20 kilometers per hour. She is half an hour late. Okay, she is 30 minutes late. 30 minutes or half an hour late. Half late. If she runs faster by 4 kilometers, if she is going at 24 kilometers per hour, she's still late by 10 minutes. 10 minutes late. So, or 10 minutes can be written as 10 by 60, she is late. So, in both, she is late. So, the difference delta T is subtraction 10 by 60, difference of 10 by 60 and half. Okay, half minus 10 by 60, subtract that time, you get 60. So 30 minus 10, 20 by 60, 1 by 3. So that is delta T. What is the distance? D is equal to delta T S1 S2 by S1 minus S2. When you write delta T here as 1 by 3, you don't have to divide by 60 because this is in hours. 10 by 10 minutes is already converted into minutes. So already converted into hours. So this is in hours. The delta T is 1/3 of an hour. So 1/3 is already in hours. S1, S2 is 20 into 24 by 24 minus 20. So 20 into 8 by 4, which is equal to 40 kilometers per hour. 40 kilometers, sorry. 40 kilometers is the distance that she is covering from the laughter club to her home. Remember, here both are late, so the time taken we are taking as the difference. If both were early, it would still be the difference. Only when one of them is early, the other is late, we add the times. A horse runs at 40 kilometers per hour and reaches the finish point 11 minutes late. It tries to run faster at 40 kilometers per hour but is still late by 5 minutes. What is the correct time taken to complete the journey? Okay. Here, 40 kilometers, 11 minutes late. This is late. 50 kilometers per hour, 5 minutes, but again late. So delta T is now not 11 plus 5, it is 11 minus 5, it is 6 minutes. It is the same as 6 by 60 hours. So what is the distance? Distance is delta T into S1, S2, okay, divided by S1 difference S2. So we get this as 5 into 40. Okay, so we get this as 20 kilometers. Is that the answer? No. They have asked what is the correct time taken to complete the journey. If the horse was running at 40 kilometers per hour, to cover 20 kilometers, it needs half an hour. Okay, so D is equal to S into T. So we get the time taken is D by S, 20 by speed. We get it as half an hour, which is equal to 30 minutes. If it was running, it is 7.11 minutes late. So if it is taking 30 minutes, it means it is 11 minutes late. So the correct time taken is 30 minus 11, 19 minutes. So if the horse took 19 minutes, it would be on time. Since it's taking 30 minutes, it is 11 minutes late. So from 30 you subtract 11 to get the correct time that the horse has to reach. So the answer is 19 minutes. If a person walks at 4/5 of his usual pace, he is 15 minutes late. How much time does it take to cover the distance if he is walking at his regular pace? So one thing that you have to remember, speed is inversely proportional to time. For people who know what directly proportional and indirectly proportional are, very good. For people who don't, what it means is if you increase the speed, the time taken to cover the same distance reduces. Or if you increase the time to cover a distance, it means your speed is lower. So if a person is walking at 4/5 of usual pace, pace means speed. If he is walking at 4/5 of his usual pace, 4/5 pace means 5/4 of the time. Okay, speed is reducing from regular pace, is becoming 4/5 pace. Time is increasing from regular time to 5/4 of the regular time. So what is it saying? 5/4 of the usual time. So 5/4 t minus t. So if you are walking at regular time, you would reach at some. If you are walking at regular pace, you would reach at some time. Now he is walking at reduced pace, which means it is taking more time. Okay, this is the regular time. This is now more time taken. That difference is 15 minutes. This is 15 minutes. So if he was walking at his regular pace, he would reach at some time. His reduced pace means his time taken is more. So the difference between those two times is 15. So this would be how much time does it take to cover? T is equal to 15. You can convert this into hours or into and keep it in minutes. 15 into 4, 60 minutes equal to 1 hour. So we've looked at 5 problems, some on both being early, some on one of them being early and late. We looked at the correct time taken to travel. We looked at the pace in this problem being a fraction of the earlier pace and the person being late. So we looked at all sorts of problems on early, late and on time. So if you like the video, please click on the thumbs up sign, shows your love. If you have any doubts, please put that in the comment section. Shows your encouragement in the comment section as well. Share this video with your friends. Let them know about our YouTube channel and subscribe and click on the bell icon so that you do not miss out on any videos. Please also check out our other playlists. And they are all useful for competitive exams and placements. Please spend some time in our playlist. And if you like what you see and you want more practice, please visit our website 7senstalent.com. Sign up, log in, and you could take some of the free tests there, be it module specific or company specific tests. I thank you once again for spending time with us, and I hope you enjoyed this video. Thank you and see you soon.